morning, everybody. Thanks for coming out. I'm very pleased to see you're here at exactly the right time because the clouds are clearing and the sun's coming out. And I apologize to lose, but I get warm out here in a bit. But we like it sunny because it's actually good for our robots. It's good for us too. I do want to especially thank all the people who have come out here today to actually make this event possible. Thanks, James, and also we have some people from NASA Marshall who are supporters of this work here. I am the project manager of the Human Exploration Telerobotics Project, or you can just refer to it as the Telerobotics Project. It is part of the Space Technology Mission Directorate, and our goal here really overall is to understand how humans and robots can really work well together. And not just any kinds of robots, we're really interested in remotely operated robots. And in particular, we're trying to understand how can you use these robots to really improve the way that humans can live and work in space. Some of the work that we're doing right now on Space Station with this project involves robots such as the Robonaut 2 humanoid robot, which was developed by the NASA Johnson Space Center in Houston. We also have a free-flying robot called Spheres, which is managed also from here at NASA Ames. And the system behind me today is the K-10 robot. It's part of a system that we call surface telerobotics, to really sort of distinguish it from the other kinds of telerobotics that NASA's done for a very long time. I'm sure many of you, if not all of you, are very familiar with the Mars Rover program, which has been a very, very successful program over the past decade to really explore the surface of Mars. One of the difficulties that we have with that kind of approach, however, is that the robots are doing all the exploration by themselves. That means that they have to be able to drive, they have to be able to move, figure out how to get from point to point. It's a very slow process. It takes a large ground control team, many people. During the initial part of the Mars Exploration Rover mission, almost 10 years ago, during the primary phase of that mission, we had 200 plus people on the ground planning and operating the robot. So a very large ground control team. Today, it's sort of the complete opposite. We have a single operator. We have astronaut Luca Promatano on the space station. He's actually an Italian astronaut. He's controlling this robot by himself. We do have a support team in the building behind you, and if you stick around to 10:45, when we're done with our test operations today, you can also go in and take a look at that. They're really just to monitor the system here on Earth and just take care of the basic logistics. Luca Promatano is 100% in control over this robot. Now, some people have asked me, how does he control this robot? Well, we've written some software that's on board the space station. It's running on a laptop computer, and actually it's a commercial commodity laptop. It's a Lenovo ThinkPad. You can go and buy one of these today. The software we've written is actually written in Java. It's designed to run on almost any kind of platform. We happen to be running it on this computer. I know that there are some of you who are very technically oriented and you might want some more technical details. Two quick things about that. One is on Space Station we are running software which is stable, and believe it or not, the software that we're running on the Lenovo is Windows XP Service Pack 3, which has not been in production for a long time. But we've added on new software. Our user interface, the Java software, is brand new software. It allows us to do things that nobody could conceive of even 10 years ago. One of the other things we've been doing is really trying to figure out how do you control these robots, how do you communicate data from space station to the robot and back. To do that, we've been using a detailed messaging system that was developed by NASA. We actually have David Mittman back here from JPL, who's been the lead within my project on this. He'll be around after I'm done here, and feel free to talk and ask him questions. Another key thing to point out here is that the testing we're doing today really has two purposes. The first objective for us, and this is really the whole reason we've set up this test, is to understand surface telerobotics. How does the system work? What are the characteristics? What are the requirements if we're going to use this in future missions? And so to do that, the testing that we're doing today involves capturing lots of information. Data about the robot, data about the communications. We're also talking to Luca and trying to assess his workload, trying to look at his level of situation awareness and how that changes over time. So that's one part, characterizing the system. The second objective, however, is to simulate a future possible mission. And to do that, we've chosen a mission scenario that involves taking a robot to the far side of the moon and deploying a radio telescope to observe the early history of the universe, the so-called cosmic dawn. This mission concept was something that was developed by the University of Colorado Boulder, and that's actually led by Dr. Jack Burns over here. He's around also. I certainly encourage you to talk with him about that. It's a really wonderfully fascinating concept of a mission. It's something that I firmly think is one of the things that NASA should do at some point in the future. We're here trying to understand how we carry this out if we go forward with this mission. The last thing I want to say is just to echo what Lou Braxton said earlier today. To me, one of the most important things about all of this work is that the technology that we develop, the technology that we test in space, from space, is stuff that we can take and transition into everyday life. I firmly believe, and this is not just because I'm a robot geek at heart, is that we will see more and more robots in our future, in our everyday lives. If we have the ability to use robots controlled from space to do work here on Earth, why can't we have robots that do work for us at far distances? Why can't I live in Hawaii and work here in California? Well, I shouldn't say that in front of my boss. Really, honestly, I think as we look to the future, the ability for us as humans to project our influence, to have capabilities that are conveyed through these avatar-like robots, robots that can work in a distance, is something that's going to go from being science fiction to being reality. And that's the kind of thing that I'm just so excited about the work that we're doing here at NASA. So thanks for coming. I'll be around all morning. I encourage you to speak with everybody here as well. We'll be resuming operations once we reestablish communications with the space station about 9:45. That will run for about 50 minutes or so. After that, the whole area is an open house. So if you stick around at 10:45, you can go onto the actual terrain. You can go up close to the robot. You can go into our operations trailer. But thanks for coming. Hope you have a good day, and talk to you very soon.